So we're going to look at the case where the object is placed between the center of curvature and the focal point. This is the situation if you've been near a spherical mirror, a concave mirror. By the way, I'm going to start increasingly using the term converging mirror, because in this case, a concave mirror is a converging mirror. It brings parallel light. Well, it always bends light so that it towards the optical axis. A diverging mirror, this example where this surface is mirrored, will always bend light away from the optic axis. So keep that in mind. So we have a converging mirror. We'll start with the three rays. We'll start with the parallel, is usually the one I start with. So it comes in parallel, strikes the mirror. Now, in this case, we're still good. It goes out through the focal point. So anything that comes in parallel, no matter where it comes from, is going to go through the focal point. This is important to note. This is why light from very distant objects, which basically comes in parallel, is brought to a focus at a single point like that. So we have the in part taken care of, then it hits the mirror, follows the law of reflection, and goes out through the focal point. Extend your line all the way to the end of your page. Because if you've experienced this with a concave mirror like this, this is the weird location where you really can't even see your image because it's being formed behind you. So, and it's large too, by the way, as you're going to find out. The next ray, the chief ray, is going to be an example of why back here I said I use the word through in quotation marks. The reason I do that is because sometimes, like in this situation, when I'm going to draw the chief ray, for example, I say here that it comes in through the center of curvature. Well, okay. It's a little bit of a stretch there, because if I start here and I head towards the center of curvature, I'm not going towards the mirror. What it means is do you agree with me, hopefully, that there is a line connecting the center and the tip of that object? It leaves the object as if it came in that direction. So what you would do, now this would be you have a ruler at your disposal. So for example, if this is my ruler, I would take my ruler and line it up so that it connects, and I don't really know if I'm going to be able to do this really well or not, but I would take my ruler and line it up so that it lines up with, this is very difficult for me to do with this program, but that's all right. You get the idea, hopefully. Lines up with the tip of the object and the center. I don't have to do that, so what I'm going to do is I'm going to do the following. I'm going to take my line and I'm going to draw it. I'm going to start, don't do this. I'm going to draw at the center, extend it through the object till it hits the mirror, boom, and then I'm just going to go back. And now that I have the spot, oops, I'm going to get rid of this end of it. So it comes from that direction. Cool? So it comes as if it came from the center, or quote, through the center, hits, and then does what? Goes right back where it came from, right? So in this case, it will eventually then pass through the center, won't it? Boom. All right, where do they meet? Down in here, right? So I kind of already have a feeling that my image is going to be somewhere in this neighborhood. Cool? So my goal with this last ray is just to verify that. And if I need to, fudge it a little bit so it comes out nicely. So last one is the focal ray. It starts by going through the focus and coming out parallel. Now what I'm going to do is I'm going to look and see where these meet. They meet right about that height. So there we go. So if I need to fudge it a little bit and come in like this and then leave and come out parallel down here, I can do that. I'm going to do this one. That looks pretty good. I'll make it happen. So there's your three rays. You have your red one is your parallel ray comes in parallel. So it goes in, here's your arrows like that, and comes out in this direction. Your chief ray comes in and out the same direction through the center. And of course, your focal ray comes in through the focal point and out parallel. Image characteristics. It's formed on the same side, for mirrors, when it's formed on the same side as the mirrored surface, it is a real image. Another sign that it's probably real is that it's inverted. Real, inverted, and in this case, it looks like it's a little larger. So when we're back in here, it's probably going to be magnified. All right, characteristics when you're in this region. And that magnification is going to get larger and larger the closer you get to the focal point. If you put a source of light at the focal point, it will actually send out parallel rays. They don't use them too much anymore, but they used to use those spotlights to get you to go to like car dealerships or whatever. They'd shine them in the sky, and you're supposed to be like, I don't know, like a moth, and be like, ooh, what's that? And go there and buy a car. I don't know why they thought this would work, but it was before the internet, so people were less jaded. Ooh, spotlights. And they would go. And they would say, do anybody here? No? Okay, you may not have an idea what I'm talking about, but they make these things that do that. So spotlights, you picture like the Hollywood movie premiere, and they're the cliche, like that, those. Well, the light source is at the focal point of probably a parabolic mirror, but that's all right, basically a spherical mirror. And that light source not only shoots light from itself, but when it hits the mirror, it comes out parallel. It looks like a focused beam. All right, so now we're going to get to our first virtual image. Because if you have experience with this, when we get nice and close to a concave or converging mirror, we see a really big virtual image of ourselves. Here's why. So, first one, focal ray comes as if it came from the focal point. So for me, using this program, I'm going to connect the two like so. If it's you, I'm just going to line up my ruler between the two. So line up your ruler between the focal point and the tip of the object. Draw your line, leaves the object, and hits the mirror. So in this case, pretty short line. And then, how's it going to come out? Ask yourself that. And the answer is parallel. So it leaves here and comes out parallel to the optic axis. If you're watching this video at home, or what I would suggest that you do is pause it and see if you can draw the central ray on your own. See if you can draw the chief ray on your own. But I'm going to forge on, so if you're still playing it, here's what I'm going to do. I'm going to line up the center with the tip of the object and then continue through till it hits. Okay. And in this case, I'm not even going to erase it because I know it goes back through there. So it's going to hit and come right back where it came from. Like so. And you're listening to this on the video, you should know that I'm doing this during a class. So what I'm about to say is, well, I'd like everybody to make sure you're looking at this right now, because the next point, we got a problem here. Where are these two rays going to meet? Well, they're sure as hell not going to meet in the real world, are they? If you look at the red and the green arrows on the left, they're diverging. There's no way they meet in the real world. That's why they call this a virtual image. They don't meet in the real world. They meet, quote, meet behind the mirror. Your eye sees the red ray of light and the green one, and assumes, because it doesn't know anything about the mechanisms of your eye, we can rationalize it and explain it all we want, but that doesn't help the eye understand what the hell is going on, right? It thinks that, for example, the red light, ooh, I did that one wrong. I did the focal ray first, didn't I? Oh, hell. What do? This is like Sal Khan. Do I make a whole nother, just forge on and then make a whole nother video? No, I got to fix. We got to fix. So, for those of you paying attention, you realize, maybe people in class here today realized and didn't want to say anything because they don't like me. I actually did, I'll make it blue. I did the focal ray first. Doesn't matter what order you do them in, by the way. But I actually did the focal ray first. It's okay, no big deal. In this case, it may actually be a good thing that I did that. Just rename it or whatever, doesn't matter. There we go. But either way, they're not meeting, are they? So, this is what I do. I trace them back just like the eye does. For example, with the blue ray here, I will line up your ruler along the, now this is the ray, make sure it's good. This is the ray that your eye sees, right? Don't trace this little one back because your eye doesn't see that. It goes between the object and the mirror. What your eye sees is what comes off of the mirror. So we're going to trace this line back, with a dotted line, which is the wrong color, but that's okay. I'm going to fix it right here, right now. We got this. Can't get my color straight today. There we go. And just dot it back. And do the same thing with the other line, which I'll leave as green. When you do that, you might be able to make a guess as to where they meet, correct? So somewhere in a place that doesn't really exist, right? The two rays will to appear to have come from that spot. And so what we have here is a virtual image. I'm guessing right in this location. Cool. Let's do our last ray and make sure everything's kosher. So now I will do the parallel ray like I should have the first time. Parallel ray starts at the tip of the object, comes in parallel, like so, but that's not the one I trace back, because after it hits, it goes out through the focal point, like so. And if I'm lucky and I'm willing to fudge things a little bit, when I trace back this one, the one my eye sees, I should get the three to meet in the same location. We'll see. Not bad. Not bad at all. So, when you're doing a ray diagram, if they don't meet in the real world and you have to trace them back, congratulations, you got a virtual image. This is, you'll know when you have a virtual image. It's, you have dotted lines all over the place. Almost there? All right. I'm going to move on. And let's look at diverging mirror. So, I'll try to start with the correct one this time. Parallel ray. So parallel ray comes in parallel, strikes the mirror. Now, it's supposed to go through the focal point. Well, there's no way in heck it actually goes through the focal point, right? It's going to bounce off the mirror. But what direction does it go? Well, guess what? I line up with the focal point and the spot where it hits, and I go in this direction. It bounces off like that, as if it came from the focal point. Cool? So diverging mirror, convex like this is what happens. So it comes in, strikes, and then goes, quote, through the focal point, or as if it came from the focal point. And our eye is going to trace that back. by the way, we know if we've ever looked at one of these, it's definitely going to form a virtual image. I'll extend that because I'm not sure where they're going to meet. Now, I'll do the chief ray, which goes as if it's going to go to the center, right? Now what I do is and when I do this, I extend it to the center, and then I note where it crosses the mirror, which is about here. So it hits here, and then goes right back out where it came from. Like so. And I'll trace that back, because I'm anticipating a virtual image. It's supposed to go through the center. Now notice, our image is going to be in this location and will be smaller, correct? Which is what we expect from the old shoplifting mirror. And you can see more things, but you got to look closely to see that I'm stealing the Milky Way bar or whatever. Not that I've ever done that. Maybe when I was little. I feel bad about it still. And they were only like a quarter at the time. But I really wanted it. The store's out of business now. I'm sure it wasn't that did it. Okay. There, I confessed. I feel better now. Last one comes in as if it's going to go through the focal point. That means if I line them up, it's going to hit about here. But then how does it come out? Parallel. So we're going to go parallel, and that's the one our eye sees. And so that's the one we're going to trace back. Sure enough, pretty much, close enough. There we go. Come on. See, it wants to snap it to horizontal, which is, yeah, anyway. Close enough. They all meet there. So, my image. Now, what are my image characteristics? Take a look at it. First of all, clearly, with all this dottedness and the fact that it's behind the mirror, virtual. Virtual image, upright, like virtual images often are. Pretty much always are, is my recollection. And in this case, reduced.